Atoms want to bond together. That's why we have molecules. That's why we have people, DNA. Our universe is based on atoms which like to bond with each other. The electron vibrates back and forth, binding them together. And that's why we have molecules. That's why we have you. You are a consequence of the fact that electrons are shared between different atoms using the laws of the quantum. Well, my favorite law of physics is the equivalence of matter and energy. Einstein's equation, E equals mc squared. This is why the sun shines. It's why the stars twinkle. It's what lights up the universe. We like to think that matter and energy are totally different things. How can a rock turn into energy? However, if that rock is uranium and that energy is the fireball of a nuclear bomb, you realize that matter and energy are two sides of the same coin. Matter energy is one unit, and they can flip into each other under certain circumstances, like in the heart of a star. Most textbooks say that an electron is a dot. Particles that we see in our atom smashers are dots. But if I had a super microscope, I can see that that dot is actually a rubber band. From a distance, this rubber band looks like a dot. Close up, you see that it's a vibrating string. Now, this rubber band can vibrate in many different modes. Each mode can be called a particle. So, for example, this might be an electron. But if you twirl it in a different way, it becomes a quark. And if you twirl it this way, you have to give it a different name. We call it a neutrino. Now, how many ways can one string vibrate? The answer is obvious. An infinite number of vibrations on the same string. And so we think that all the subatomic particles of the universe, the quarks, the neutrinos, the mesons, the protons and neutrons, there's a galaxy of these particles. They're nothing but musical notes on a tiny rubber band. A rubber band so small that it looks like a dot. So what is physics that we had to struggle with in high school? Physics is the harmonies of vibrating strings. Physics tells us how these vibrations move. What is chemistry? Chemistry is when these strings bump into each other and form molecules. That inside the proton, there are three quarks, subatomic particles that make up the protons and neutrons, which in turn make up our universe. Einstein says we live in a four-dimensional world. We can go forward, backward, left, right, up, down, and the fourth dimension is time. But now we're beyond Einstein. And we have to go beyond 4 dimensions to perhaps, let's say, 10, 11 dimensions. But where are these other dimensions? We think they have curled up. They're so small that you cannot enter them. But perhaps we can feel their effects. And where is this other dimension? It is off the plane of your universe. Perhaps a parallel universe hovering right above your universe in another dimension that we cannot see or touch, but perhaps there's a gateway connecting them. That gateway is the wormhole. It was Einstein himself in 1935 who introduced the concept of a wormhole, a gateway between higher dimensional universes. Quote, where Einstein said, "The more successful the quantum theory gets, the sillier it looks." He thought that atomic physics, that is, quantum mechanics, was incomplete. When the Nobel Prize was given to people like Heisenberg, he said, yes, give them the Nobel Prize. They're onto something. And so Einstein had reservations about the quantum theory as the final theory. He thought there had to be a higher theory, a theory even beyond the quantum theory. So Einstein was not totally incorrect. Well, Einstein spent the last 30 years of his life chasing after the God equation, an equation perhaps no more than 1 inch long that would allow us to, quote, read the mind of God. A theory that would unite the two branches of physics. On one hand, we have the theory of the big, general relativity, black holes, big bangs, and the theory of the small, quantum theory, atomic physics. How can you unite these two into one theory? At the present time, these two theories hate each other. They're based on different mathematics, different principles, different concepts, and yet we believe in our heart of hearts there has to be a master theory out there, the holy grail of physics. And that, we think, is the God equation. The leading and only candidate for that is string theory. And by the way, if you ever find the God equation, tell me first. We'll split the Nobel Prize money together, you and me. Light can bend around corners. In fact, that's why we have glass inside your glasses. When light goes into glass, it slows down slightly. Because it slows down, it deviates from a straight line. And that's why we have your glasses, telescopes, microscopes, because glass bends light. Also, gravity can bend light, as Einstein showed us, and we can actually see the bending of light as it goes around a galaxy. Then the next question is, can you bend light completely around an object so the object becomes invisible? And the answer is yes. It's well within the laws of physics that if you could govern the atomic structure of glass, then light would bend in a way such that it would completely go around an object, so anything inside that object becomes invisible. One day we will build a metamaterial out of nanotechnology that will bend visible light so that anything inside that capsule will become invisible. Harry Potter, watch out. Time does not beat uniformly throughout the universe. Clocks on the moon beat a little bit faster than clocks on the planet Earth. On Jupiter, clocks beat slower than on the planet Earth. The heavier the planet, the slower time beats. This means that on a star like the sun, time beats even slower. And the ultimate star, of course, is the black hole, the remnants of a dying star. We think that at the very center of the black hole, time stops. What does that mean if you were to fall into a black hole? From your point of view, it would take perhaps a few minutes, let's say, to fall through a black hole, depending upon where you started from. Your watch says that you went right through to the center of the black hole. But from outside, somebody with a telescope looking at you from outer space would see you frozen in time, slowly going into the black hole, because time beats at a different rate from the outside and the inside. Get your head around this. Time can beat at different rates at different points in the universe. We know that if I take a gigantic star or galaxy and compress it, its gravity is so great that nothing known to science can escape the clutches of gravity. So light itself is trapped by the black hole, and according to textbooks, it collapses to a point of infinite density. Let's be real about this. There's no such thing as infinite density. We just say that in textbooks because we don't know what happens when a star collapses into a tiny dot. Infinite density is a shorthand of saying, I don't know. We really don't know what happens at the very center of a black hole. If you do the mathematics very carefully, you realize that the black hole is spinning, and spinning stars collapse to a ring. They don't collapse to a dot at all. And if you fall through the ring, the mathematics says that you fall not just to the ring, but you fall to the other side to a parallel universe. That is, on the other side of a black hole, there's a white hole. Everything that falls in gets blown out the other end